Okay, so today we're going to fit a line to data and predict with linear models. So this is actually in a unit you may have done called, what's it called? The Overland Trail, right? So this is using linear regression. And essentially you're predicting what can happen based on data that you already have. Okay, so let's do some definitions. So we have scatter plot, which is a graph used to determine whether there is a relationship between paired data that show trends. Okay. And then we have interpolation, which is using an equation to approximate a value between known values. And then we have extrapolation, which you might have heard before. You might have heard extrapolate. Using an equation to approximate the value outside the known range of values. Right? So extrapolate you might have heard before, right? You're like, oh, you know, if I continue to spend $10 a week on coffee, then in a year I'm gonna spend $520, right? So that's extrapolating, right? You don't have data for the whole year, but you're approximating a value outside of that week of data that you have. You can also hear it sometimes in like psychology stuff, like, oh, you know, like if like, or like in science, right? Like experiments, like if this bird type always drinks water from this water source, then all bird types are going to drink from that water source, right? So that's like extrapolating, is like predicting. Okay, so we have positive correlation, negative correlation, and no correlation. So this is what they look like. Positive correlation is going to generally be trending upwards, like a positive slope, right? All the dots are not going to always be on that line, but it's going to be near it, right? Negative correlation is similar, right? Sometimes we can have like an outlier, like that, but in general, right, outlier is a vocab term, right? In general, it's negative correlation. And then no correlation, you can't really tell what's going on, right? Just dots are all over, sort of random. Nothing's going up, nothing's going down, right? No correlation. All right, best fitting line, the line that most closely follows a trend in data. About half the data is above and half is below. Right, so if we look at here, we had our best fitting line, and about half the dots are above and about half of them are below. Right, and then linear regression, right, we talked about that at the top. Linear regression is the process to find the best fitting line. We'll use the calculator. Okay. So these are the instructions. They're a little hard to read, but if you read through them all, you will be able to find this. So this is our example, right? our best fit. We want to find the best fitting line. Okay, so the first thing that we have to do is we have to enter the data into two lists, L1 and L2. So we're going to hit stat. Right, we're going to hit stat. We're going to hit edit. And then we're going to fill in our data points. So let me clear out these. So the lighting isn't great in this room. Okay, so we're going to enter it in. So we have our X's and our Y's. So this is going to be our L1. This is going to be our L2, right? So we just type it in one at a time, enter, -1, enter, 0, enter, 1, enter, 2, enter, 3, enter. And then over here we have 4, 2, 1, -2, -1, -2. Okay, so we entered our data, and now we need to get their regression. So we go stat, we go to calc, choose 4 linear regression, so we can either scroll down, or we could just straight up hit 4. And then we just go all the way to calculate, and it gives us this equation. So it gives us, right, so it says here, the coefficients of your linear regression equation A and B will be displayed on your home screen. Linear regression equation will be stored in equation editor to Y1. Okay, so right, this is very familiar, right? This is y equals mx plus b, but instead of m, they made it a. I don't know why, just to make your life more difficult, right? So we have, right here, we have y equals ax plus b, but we have a is negative 1.2 and b is negative 9.3, repeating. So I'm going to rewrite this, y equals negative 1.2 x minus 0.9333, right? You could usually do 3 decimal places, but I just did 4. Okay, so let's take a look at this first. So if we look at, if we look at the data, right, if you just type graph, you can see the scatter plot. If you go to stat plot, this will turn it on. So let's do this, right? To see scatter plot, go to turn on plot 1, and you can see it. And then if you go to y equals, you can type in your equation, right? So I have negative 1.2 x minus 0.9333. And if I graph it, it should graph. If it's still not showing up, you could go to y equals and make sure this is like highlighted. So if it's not, you can just push, and you go over to it and push enter, right? So that will make it go away. Right now it's just the dots, but if I highlight it, you can see it, right? And now I can see both. I can see the line and the points, right? So based on these, 6 data points, they created a whole line for me. And these are the steps to see the line. Okay. So let's try another one. So whenever we're putting in new data, right, we go stat, edit. You can just go to the very top of L1 and push clear. Okay, so you can, to clear it, you can go up to the L1 or L2 and push clear, and it'll clear everything. So that it doesn't, saves you some time, right? Clear. To clear, right? Highlight L1, L2, and press clear. Okay, so we're gonna put these in. Negative 1, 0, 1, 2, 4, 3, 3, 1, 0, negative 3. Let's clear out this equation so we can see what it looks like. Okay, so here are our plot points. So if we look at it too, we could see that this is a negative correlation, right? So our equation should have a negative slope. So we're gonna go stat, we're going to go down to linear regression or just type 4, go through, push enter, 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 and we have this beautiful equation. We have y equals negative 1.27 x plus 2.32, right? This is a negative slope, so at least we know that we're on the right track there. We're going to highlight it, turn it back on. Oh wait, we need to put something in there first. 1.27x plus 2.32. It's already turned on, and we're going to graph it. And look at it, added that line right on top. Right, I just click graph. And so we found our equation of best fit. Now you want to approximate the value of y for x equals 3 and x equals 10. So this is as simple as just plugging in x equals 3, right? So y equals negative 1.273 plus 2.32, and y equals negative 1.710 plus 2.32. Okay, so with our calculator, we could just plug in negative 1.273 plus 2.32, negative 1.2710 plus 2.32. So we get negative 1.47, 1.9, and negative 10.38. So this one, right, they gave us the x, and we had to find the y. This one, they gave us the y, we need to find the x. Right, so this is the whole point of this unit, right? This unit is called Predict with Linear Models, right? So this this right here is interpolate, because 3 is between the x values that we had. And then here, this is extrapolate, right? Because 10 is beyond the range that we had, right? So if we're looking at this graph, this is the line that we have, right? Here we can see 3 is somewhere in between here, right? Like negative 1.4. But the whole point of this unit, or this like section, is like predicting, right? So it asks us to figure out what would happen when x equals 10, right? And it's all the way over here, and then it's like all the way down here. So this whole unit, right, is like we give these points, right? We have these points, we use it to make a line, and then we use that line to predict things that we don't know about, right? And you can do this without just numbers, right? So like let's say I've only seen 5 dogs before, right? And I'm like, okay, the 5 dogs I've seen have all had fur, and they're all small dogs. So I could extrapolate and say every single dog is small and has fur. And that might not always be right, right? The extrapolation isn't always right, but sometimes it is, right? I could say, oh, all the cats I've seen have whiskers, right? And then I could extrapolate, like every cat has whiskers, which is pretty much true. So here it's just different, it's with numbers, right? These are the 5 points I've seen. This is the trend that I found. And I'm assuming that no matter, like, all the other points will exist on this trend. Okay, so here we're extrapolating again, but this time we're given y. So we're trying to use this, right? And we're like, okay, we think y is all the way down here at negative 18. What is the x value? So we're gonna subtract from both sides. We're solving for x. So we get negative 18 minus 2.32. We get negative 20.32 equals negative 1.7x. Divide by negative 1.7. Oops. Divide by. So we have negative 20.32 divided by negative 1.27, and we get x equals 16, right? And let's just double check that to make sure it's true. Let's plug it back. Negative 1.27 times 16 plus 2.32, negative 18, right? So it's saying what is x when y is 18? If x is 16, then y is 18. Okay, so we're almost done. We just have to find the 0, right? So these are the answers to this problem. This is the answer to this problem. And let's do the zero of a function. So this one is saying y equals 0. So we have 0 equals negative 1.27 x plus 2.32. We're going to subtract negative 1.27, negative 1.27, negative 2.32 divided by negative 1. Then we get 1.83. Right, so we found the 0. That's when y equals 0. If we look on this graph, we can see when x is 1.83, y is 0. We could also do this using trace. So we could do, not trace, sorry, calc. So we do second trace, which is calc. We do 0. And we go a little bit to the left of the 0, a little bit to the right of the 0. Push enter, and then it sees there 1.83. So that's another way you can do it with the calculator rather than algebraically. Okay, and then we have a try this problem. So use the following line of best fit. Y equals negative 0.02x plus 1.435. 1. Okay, so first I'm going to do algebraically, and then I'm going to do it with the calculator. Okay, so this is giving us x, so we need to find y. So we have negative plus 1.435, 1.355. Right, it gave us an x, our answer is a y. And then we find the 0, so that's when y equals 0. Minus 1.435 from both sides. Divide by 0.02. Right, so it gave us an x, or it gave us a y, it said y is 0, and our answer is an x. And then let me just show you real quick on the graph. So we have negative 0.02 x plus 1.435. Let's take away this the stat plot, turn it off. Look at the graph. Oh, that's not right. Oh, is it? Oh yeah, the slope is very small, so that is right. So we're going to go to table. We're going to plug in 4, and we get 1.355. And then this one is harder to find the 0 because the slope is so thin. But if we wanted to, we could say x is 20 to 80. Right? So there's the graph. We want to figure out when it crosses 0. So we could do second trace, 0, left, all the way to the right. We got 71.75. Alright, so that's it.